a line segment is part of a line. It begins at one point and ends at a point. A midpoint divides a line segment into two equal line segments. A midpoint divides a line segment into two equal line segments. Okay, so if we had a little diagram here, we have the line AB with midpoint M, where M divides AB into two equal line segments, AM and MB. They have equal length. So let's say we were on a Cartesian grid, that is our graph paper, the Cartesian grid, and we have 2 points, and between the 2 points is drawn a line segment, and we need to find the middle of that line segment. What would we do? Ready? Example 1. Find a midpoint. So we're given a Cartesian grid. We have our y-axis and our x-axis both properly labeled. We are going up by, well, we can go up, we'll just label 2's, but 2, 4, 6, 8, 10, 12, and 2, 4, 6, 8, 10, 12. All right, so here is our Cartesian grid, and we are told that a city has 2 hospitals. They are shown on the map at coordinates A, which is the place 3, 5. So here is a hospital. This is hospital A at 3, 5. And we are told they have a hospital at the point B, which is 11, 14. We're not going to make it to 11, 14, so we won't do 11, 14. We'll do 11, 12. 11, 12. So they have hospital B at 11, 12. The city wants to build a new ambulance station halfway between the 2 hospitals. Determine the coordinates of this location. So they've gridded out their whole city, kind of placed it over top of a Cartesian plane or placed a plane over top of it. And they want to find out the midpoint between A and B for the best location to place an ambulance station. So the first step that we had to do was draw the line AB. So now we have a line segment AB, okay? And now we can simply find the midpoint of both things. So I'm going to show you step by step. We're going to draw the x's, and we're going to draw the change in y. So the change in x happens along the x-axis here. The change in x between A and B, just by drawing a right angle triangle here, So that dotted line represents the change in x. So just horizontally, that's how far away A is from B. So the change in x means we have an x coordinate of 3 and an x coordinate of 11. So the change in x means the difference between x2 and x1. Okay, so x that belongs to point B and x that belongs to point A. This line represents the difference between those 2 points. Okay, so just quickly we can talk about it. This point is 11 and this point is 3. Then the difference in between them should be 8, right? Well, let's see what happened. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that shows the difference just horizontally between the x values, between x2 and x1. Because whenever we have 2 points, we have 2 sets of xy's. This xy was drawn second, it's point B, so it can be called x2 and y2, whereas this one is going to be called x1 and y1. Okay? Hopefully you can still see if I do some math on this graph paper. But in order to find out how far we have run, so the run, this is method 1. You can call this method 1. The run is the x value in x2 minus x1. The run is x2 minus x1, which equals 11 minus 3, which is 8. So the run is 8. The rise, you can represent it by another dotted line here, going from just our vertical change between A and B. Okay, there's our rise. Our rise is equal to y2 minus y1. Now what I really need to make sure of is that if I've done x2 minus x1, I need to do y2 minus y1. I could have also done x1 minus x2, but then I would have to make sure that I did y1 minus y2. Okay, but generally you take the second point and you subtract from that the first point. So y2 minus y1 is the easiest thing to remember, easiest thing to do. Okay, so what is y2? y2 here is 12, and y1 is 5. So we've got 12 take away 5, which equals 7. I'm going to just put this off to the side so that I can do some math on the whiteboard again. So the coordinates, therefore, we have a therefore statement. I'll bring here, maybe I can bring this off right there. So there's our rise and our run. Therefore, the coordinates of the midpoint are xy equals. So now we're going, use the picture again to describe what's going to happen. So to find the midpoint of this line, we want to go horizontally halfway, and vertically we want to go halfway. Okay, so if we go halfway horizontally and halfway vertically, we will find the midpoint of our line. Does that make sense? Because we would have gone half the horizontal distance and half the vertical distance, which has to be halfway to point B. So what we're going to see here with the new coordinates, we're going to change our coordinates. X of our midpoint, so this is for the midpoint, is not going to be just x1. It's going to be x1, which is down here at 3, okay, this is x1, plus half of the run, okay, because x is only the run. And we said we had a run of 8, so we're going to have a half of the run. So we have a run over 2. That means half of the run. The y coordinate, the vertical midpoint, is done very much similar. So we have y1, which means we're starting down here at A again, and now we're going up. We determined that the rise was 7, but we only want to go halfway up. So it's whatever was at y1 plus half of the distance between B and A vertically. So it is the rise divided by 2. There is a second method that will help clear all this up as well. But basically all we've done is we've started at A, and horizontally we went halfway, right? Run divided by 2. We added that to our x1, which is 3. And then vertically we start at 5, and we're going to add half of the distance between A and B vertically. Okay, so it makes perfect sense. It's going to find our midpoint. But here we go. Let's sub in our values. So x1 was 3. Our run was 8. So we have half of that, but we'll just leave it as 8 over 2 for now. y1 was 5. Okay, the vertical coordinate of the point A was 5, plus our rise, which was 7, and we only want half of it. I'm going to do these next 2 steps in one. So our x coordinate is 3 plus 8 over 2. Well, 8 over 2 is 4. So 4 plus 3 is 7. And then we have 5 plus 7 divided by 2. 7 divided by 2 is 3.5, plus 5 is 8.5. So if we did this correctly, then our midpoint should be found at the point 7, 8.5. And we can double check our picture. Maybe I can erase this so you can see through it. Maybe not. Put the picture over here. So here's our picture, and it is going through a y coordinate of 8.5, right? Here's 8, here's 9, it's right in the middle, that's 8.5. And the x coordinate should be 7. Yep, right here, hits at 7. Okay? So all we did was we started at x1, y1, and then we added half of the run to x, which is horizontal, and we added half of the rise to y, which is vertical. Those were x1 and y1, point A. So if you need a little note here, point A was x1, y1. It was at 3, 5. Could we have started with B? Then what would we have had to done instead of adding half of the rise and run? We would have had to take away half of the rise and take away half of the run, right? It's always easier to start from a point and go forward, up and to the right. Okay, that was method 1. Method 2, I have a feeling you will like a little bit better. Can I clear this board? Okay. Was that a no or a yes? Yeah, it's too late anyway. Okay, method 2. Yeah, method 2 is nicer. What if there are no boxes? Is 11:09. Use the formula for finding the mean What is the mean? Just the average, okay? So again, I'll write our 2 points here. We have the point A at 3, 5, and B at 11, 12. To find the midpoint, all I have to do is find the average of my x's and the average of my y. So the midpoint, the coordinates of the midpoint are xy, and that xy, the x for that xy ordered pair is going to be the average of x1 and x2. So to find the average of anything, all I have to do is add them together and divide by 2. Right? Divide by as many points as there are. Which means my y coordinate for my midpoint is going to be y1 plus y2 divided by 2. And now we just plug in what we know. We know x1 and x2. That's 3 plus 11 over 2. And we know y1 and we know y2. That's 5 plus 12 over 2. Good. The first one is 3 plus 11, which is 14, then divided by 2, which is 7. And the second one is 5 plus 12, which is 17, divided by 2, which is 8.5. And we got... If you are expressing them as points on the coordinate plane, you can use decimals. Good question. That gives you the midpoint. So if you had 2 points, A, B, you could easily find the exact middle of AB. Okay, in example 2, we are trying to determine the median of a triangle. First, we need to know what a median is. A median is the name that we give to a line segment. So a median is a line segment joining a vertex of a triangle to the midpoint of the opposite side. So here we have a triangle drawn, and this works with any triangle of any shape and size. You can find the median or one of the medians. And we're just going from one of the vertices, we're going to go from this point here, to the midpoint of the opposite side. So here's the opposite side, and I've already measured it out. There's the midpoint. And now the median is simply the line between those 2 points, from the vertex to the midpoint of the opposite side. Well, now that we know the median is, we can go ahead and continue on with example 2. Example 2 gives us a triangle ABC, and it gives us the coordinates of each of the points. We have the vertex A at -3, 3, the vertex C at 5, 2, and the vertex B at 2, -5. And my triangle looks something like your triangle. And the question asks us to find an equation for the median from vertex C. So there's only one median from vertex C. It's from this vertex to the opposite midpoint. So this is the only possible line, and our goal is to find an equation for that line. Well, in order to find an equation for that line, I need the slope and the y-intercept, right? It's going to be a linear equation, y equals mx plus b. Before I can get the slope, I need 2 points in order on the line to get the slope of the line. Well, we know that my second point is going to be right here. M, the midpoint of AB, is going to be the second point on my line. So our first step then is to find the coordinates of point M. Find the coordinates of point M is step 1. And I know that it's going to have the coordinates x, y. And from our previous example, I even know how to find those coordinates. It's going to be the mean of my two x coordinates, x1 plus x2 over 2, and the mean of my two y coordinates, that's y1 plus y2 over 2. And so I'm using the points A and B to find the point M. So let's make point A have x1, y1, and point B can have x2, y2, and we'll sub in those values. So for our x coordinate, we get negative 3 plus 2 over 2. And here for our y coordinate, we get positive 3 plus negative 5. That's the same as minus 5 over 2. Negative 3 plus 2 is negative 1. Divided by 2 is negative 1/2 in the x-coordinate. And the y-coordinate is 3 minus 5, that's negative 2, over 2, that reduces to negative 1. So there we have the coordinates of the midpoint. I'll add those to my diagram so that we can keep track of all of our information here. Well, now that I have 2 points on that line, on that median, the next step is going to be to find the slope of the median CM. So I'm going to clear the work that I've done here. I'm going to use this point, M and C, to find the slope of that median. So step 2 is to find the slope of the median. Well, we know that slope is represented by M in our linear equation, and it's simply rise over run, which means that it's the change in y value. So y goes from here to here, that's our rise, over run, which is the change in our x coordinate from here to here. Okay, so let's see. We have a rise going from M, our y coordinate, to show our rise from negative 1 to 2. That's a rise of 3. And we have a run from negative 1/2 to 5. That's 5.5 as a run. Let's show that mathematically. Okay, so we've got over here our new points. We're going to do rise over run, which is the change in y over the change in x. So the change in y is just y2 minus y1. Change in x is x2 minus x1. We need to decide which of our points is going to be x1, y1, and which of our points is going to be x2, y2. And it doesn't matter which point you choose, as long as you're consistent. Okay, so we're going to start with point C as y2 and x2. Gives us on the top 2 minus negative 1 over 5 minus negative 1/2. That's 2 plus 1, which is 3. And this is 5 plus 1/2, which is 5.5. And we could use our calculator at this point, or we could continue to use fractions. 5.5 is 11 over 2. We can multiply, cross multiply here, which ends up giving us 3 times 2 over 11. which is 6 over 11. And now we're dealing with a slope. So it's okay to leave our slope in rational form. That gives us right away the rise over run if we're thinking about graphing it. And that's no problem at all. It's a rise of 6 and a run of 11. Okay, so we have our slope of 6 over 11. And remember, our goal is to come up with an equation for the median. So we need a linear equation in the form mx plus b. Well, we know what m is. And we know two of the points that are on the line. We know that m is on the line, so x, y coordinates of m will satisfy this equation. And the point C is on the line, 5, 2, will satisfy this equation. But we're not sure what b is, our y-intercept. And we need it in order to express this as a linear equation. So all I need to do is substitute in the values of x and y from one of my points. I'm going to use point C, because I'd rather not work with this fraction and the negative numbers here from point M. I'm going to substitute the values of x and y from point C into our equation, which will leave me with one variable that I'll be able to solve. And after I find that, I can put it back into our equation of a line. So here we go. Y is 2, and that equals 6 over 11 times x, which is 5. Now I know this is true because this point is on the line. Plus b. Now all I need to do is rearrange and use my algebra skills in order to get b by itself and the rest of the information on the other side. So I'm going to multiply this out here, top times top, bottom times bottom. That leaves me with 2 equals 30 over 11 plus b. Now I'm going to go ahead and subtract 30 over 11 from both sides. And in order to do that, I need to convert this 2 into a fraction over 11, because when we're adding and subtracting fractions, we need a common denominator. So we have 22 over 11, that's the same as 2, minus 30 over 11 equals b. We've subtracted 30 over 11 from both sides. 22 minus 30 is negative 8. b equals negative 8 over 11. And now I have all the information that I need to write an equation for the median MC. Therefore, an equation for the median MC is y equals 6 over 11x minus 8 over 11. And don't be thrown off by the fractions. Fractions are okay. Just a simple little multiplication here with the fraction and a bit of adding and subtracting with the fraction, and we come up with the formula, the equation of our line. Let's read example 3 together. This time we're talking about the equation of a right bisector. Now a right bisector is the line that passes through the midpoint of a line segment and intersects it at a 90-degree angle. So if I could draw that for you, a right bisector, take any old line segment, it's got a point there and a point there. The right bisector crosses through the midpoint of that line, and it crosses through at a 90-degree angle. So this line is the right bisector of the line segment AB. Equidistant from both points and crosses at a 90 degree. And what you'll notice is if we pick a point on our right bisector, let's say this point, it is also equidistant from point A and from point B. Or if we picked a point all the way here, if we extended our right bisector, this point is still equidistant from B and from A. And that's how we're going to apply our knowledge of right bisectors in the next example. So we have two schools.
They're located at the points P and Q on a town map. The school board is planning a new sports complex to be used by both schools. The board wants to find a location equidistant from the two schools. So this sports complex is going to be the same distance from school P and school Q. Use an equation to represent the possible locations for the sports complex. Use an equation, so a linear equation, y equals mx plus b, to represent the possible locations of the sports complex. Well, we've just talked about this. How any point on here will be equidistant from A and B. We're going to apply that same knowledge to our schools at the points P and Q. The new sports center has to be equidistant from B and A, which means it can actually fall anywhere on the right bisector. Still not really sure what this is going to look like, so step one for me is drawing a diagram. They've given me 2 points of schools. So I'm going to go ahead and draw a Cartesian grid here. And mine's not going to end up being perfect, but you'll get the picture. We've got our y-axis, our x-axis, we've got our arrows so that I'm doing it correctly. And now we're going to plot our 2 points. We've been given that one school is at the point P, which is -1, 4, somewhere up here. P is -1, 4. And the other school is down here at 7, -2. So Q is 7, -2. The sports complex has to be equidistant from each of those schools. So what I'm really looking for is the right bisector of this line segment. If they put the sportsplex right in the middle at the median of PQ, that would be equidistant from both, but that's not the only option. It can be anywhere along this right bisector. Alright, so let's figure out all the possible locations. Step one, after we've made sense of the problem, we know what we're looking for. We're looking for the right bisector. So in order to determine the equation for the right bisector, well, first I'm going to need the slope of the right bisector. But I don't have any points that are on my right bisector, so how do I find the slope? Well, they've told us that a right bisector meets the line at a 90-degree angle, which means it's going to have a slope that is the opposite reciprocal of the line PQ. Let's work through that. So we're going to determine first the slope of PQ, because the slope of our perpendicular line is going to be the opposite reciprocal of this. So remember, slope is the rise over run, which is y2 minus y1 over x2 minus x1. Again, doesn't matter which points you use for 2 and 1 as long as you're consistent. You go 4 minus -2 over x2, which would be -1 minus 7. 4 minus -2 is 4 plus 2, that's 6. -1 minus 7 is -8, and we can reduce this fraction to -3 over 4. So there's our slope of PQ. The slope of PQ is -3 over 4. As it drops 3, it runs 4. Drops 3, runs 4, and you can kind of see that there. Now, perpendicular lines have a slope that is a negative reciprocal of each other. Negative reciprocal of each other. Negative just means we're going to swap the sign, and reciprocal means the numerator and the denominator are going to swap places. So the slope of any line that is perpendicular to this slope is simply positive 4 over 3. It's the negative reciprocal. It's the change the sign and flip the numerator and the denominator. Now we've created a line that goes up 4 over 3, up 4 over 3. And if I do that against this line, you can kind of see up 4 over 3, up 4 over 3, up 4 over 3. We're drawing a line that's kind of like this. Yeah, that's perpendicular. Okay? The second criteria that needs to be met for the right bisector is that it needs to go through the midpoint. Okay? So now what we're going to do is find the midpoint of PQ. So we'll save this information and we'll get right into finding the midpoint of PQ. So the midpoint of PQ has the coordinates x, y. And we know that the midpoint has an x-coordinate, that is the mean of the two x's. And we can simply sub in those values from the points P and Q. So we have -1 plus 7 over 2 for our x-coordinate, and we have 4 plus -2 over 2 for our y-coordinate. -1 plus 7 is 6. 6 over 2 is 3. 4 plus -2 is 4 minus 2, which is just 2. 2 over 2 is 1. So the midpoint falls at 3, 1. I can go ahead and add that to my diagram. So there's the midpoint at 3, 1. Now I have the slope of the line. I have a point on the line. Well, now all I need to do is use the coordinates of this new point, which falls on the line, and the slope of the line, which we decided was positive 4 over 3, to use the equation, linear equation, y equals mx plus b, to find our y-intercept. So here we go. We're looking for y equals mx plus b. We know that m is 4 over 3. And we know that the point 3, 1 satisfies this equation because we know that 3, 1 is on the right bisector. So we can sub in 1 for y and 3 for x. And that will allow us to solve for b, which is going to be our y-intercept. 4 times 3 is 12, divided by 3 is 4. In a sense, what we've just done is 3 is in the numerator, we've canceled out both our 3's. So we're left with 1 equals 4 plus b. Subtract 4 from both sides, and I'm just going to cheat a little bit, come up to here. Subtract 4 from both sides, b equals -3. So now we know that the equation of the right bisector is y equals 4 over 3x, that's our slope, minus 3. And any point on this line will satisfy the requirements of the sports stadium. Any point on that line will be equidistant from school Q and school P. Your homework for lesson 2.1 is on the worksheet. The worksheet is called 2.3, confusingly enough, and just the ones that are circled. Enjoy.